Okay, now we're going to look at the geometric distribution, and we're going to compare that to the binomial distribution. So, for example, Mr. Flores was very shy as a high school student and had trouble getting girls to say yes when he asked them out on a date. Sadly, in fact, only 10% of the girls he asked out agreed to go out with him. Suppose that P equals 0.10 is the probability that any randomly selected girl would agree to go out with him. Mr. Flores desperately wanted a date for the prom. What is the probability that the first 4 girls he asked said no and the 5th said yes? How many girls could he expect to ask out before the first one said yes? Okay, before we start answering those questions, we're going to look at what makes this geometric. Okay, very similar to binomial is that there are 2 outcomes. There's a success and there's a failure. Success is getting the girl to say yes, and failure is getting the girl to say no. So this is also the same as binomial. Okay, the trials are independent in the sense that the answer from one girl will not change or influence the answer of the next girl. That is the same for binomial and geometric. The probability of success is the same for each trial. For each girl, it's 0.10. That is the same for binomial and geometric. There is not a fixed number of trials. N is not fixed. There is no N. This is what makes something geometric as opposed to binomial. Everything else seems to be the same. So the key word that we looked for here is first. When is the first girl going to say yes? When will you get the first heart in the stack of cards? When will you first roll a 3? Okay, so it's when something happens the first time. You don't know how many times it will happen. There is no N. Here is the 4 conditions listed out individually. Please look on page 840, or look at problem 8.41 to describe if these are a geometric setting, and this is part of your homework or classwork for tomorrow. And then here's the formal definition of this and some examples. Flip a coin until you get a head. Roll a die until you get a 3. Attempt a 3-pointer until you make a basket. So how is this different? If you are repeating trials until your first success, that is binomial. Whenever you are geometric. If you're doing something until you're first, that is geometric. You don't know in advance how many trials you will need. Theoretically, it could take forever. So no, known, N. If you are counting the number of successes in a specific number of trials, that's binomial. So we are looking for number of successes in N, a specific number of trials. Okay, so how are you going to do geometric? Well, essentially all you're doing is using common sense probability. Okay, so if we look at the Mr. Flores example, what is happening? Okay, what is the probability that the first 4 girls say no and the last girl, the 5th girl, says yes? So what is he getting? He's getting a no, a no, a no, a no, and a yes. What is the probability that that happens? Well, what's the probability somebody says no? That's 0.9. Again, 0.9, another 0.9, another 0.9, and this girl says yes, that's 0.1. So this is 0.9 to the 4th power. You get 4 no's and 1 yes. Okay, so that's exactly what this says right here. These are all your no's or your failures. And then your 1 success. Okay. Another way to calculate geometric is if you're looking for more than blank trials to see the first success. What is the probability that it takes Flo more than 11 girls before he hears yes? Okay, what is the probability it takes more than 11 girls before he hears yes? All you know is that the first 11 are all no's. So these are all the no's. This is 0.9 to the 11th power. So those are all no's, and then anything after that can be a yes. So probability more than a specific number of trials is just the number of failures to that power. Okay, so here's how you do it on the calculator. You can read through this. You're welcome to use this. I think these make much more sense by hand. So we're going to do them by hand. Okay, here's an example where we have to decide first if these are binomial or geometric. So 13% of people are left-handed. What is the probability that the first lefty is a fifth person chosen? So this key word here, first, should be your clue that this is geometric. So we put a big G out to the side. So there's your formula. But if we just think logically about it, we know we're going to have righty, 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 lefty. Okay, so what's probability? Somebody's right-handed. So probability of left-handed is 0.13. So P is 0.13, which makes 1 minus P, or the failure, or the right-handed person, 0.87. So we're going to have 0.87 times 0.87 times 0.87 times 0.87 times 0.13. Righty, 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 lefty, which is going to be 0.87 to the fourth times 0.13, which follows from this formula. 1 minus P, that's your 0.87, to the 5 minus 1, or 4. Okay, so that's geometric. What is the probability there's one lefty chosen out of 5 people? That means we can have righty, 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 lefty, or righty, 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 nope, lefty, righty, or righty, righty, lefty, righty, lefty, righty, or righty, lefty, righty, 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 or lefty, righty, 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 righty. So those are all different ways we can fulfill that. So the way we're going to do that is we're going to say N choose K. N is our 5 people total. So we're going to have 5 choose K, which is 1 lefty. And when you type that in your calculator, you're going to get 5. 1, 2, 3, 4, 5. Those are the 5 different ways. Times P, which is your success. So that's 1 lefty and 4 righties. So there's 5 choose 1 would be 5. So there's 5 different ways to get 1 lefty and 4 righties. So again, we're following the formulas here, but essentially we're thinking through these with some common sense. Okay, so if you would please do these on your own, and we will go through them in class tomorrow, but make sure you attempt them on your own so that you know what we're talking about. Have a great day.